So this is May 2023, Maths AASL Paper 1, Time Zone 1, Question 7. The function h is defined by hx equals 2x e to the x plus 3. X is real. The following diagram shows part of the graph of h which has a local minimum at point A. So part A of the question, find the value of the y-intercept. So at the y-intercept, x equals 0. So y equals 2x e to the x plus 3. And when x is 0, y equals 2 times 0 e to the power 0 plus 3. So y equals 3. Part B, find h dash of x. hx equals 2x e to the x plus 3. H dash of x is the first derivative, so you have to differentiate the expression 2x e to the x plus 3. 2x e to the x is a function 2x multiplied by another function e to the x. So for this, you need to use the product rule. So you'd say that 2x equals u, e to the x is v, and the product rule is that v du by dx plus u dv by dx gives you the first derivative of a function multiplied by another function. So in this case, h dash x equals v e to the x times du by dx, which is 2, plus u, 2x, times dv by dx, which is e to the x, and plus 3, that just disappears when you differentiate it. So then h dash x equals 2 e to the x plus 2x e to the x. Part C, hence find the coordinates of A. So with C, so if you look at the graph, at point A, it's a turning point. And at a turning point, the first derivative equals 0. So in this case, this means at A, h dash x equals 0. So h dash x equals 0. So that means 2 e to the x plus 2x e to the x equals 0. And to solve that, you'd factorize. So you take out 2 e to the x as a common factor. So that gives you 2 e to the x brackets 1 plus x equals 0. So in this case, 2 e to the x equals 0, but e to the x never equals 0. So 2 e to the power x does not equal 0, so that's not part of the solution, but 1 plus x can equal 0, so x equals minus 1. So we've found the x-coordinate of point A, and to find the corresponding y-coordinate, you need to substitute minus 1 into h of x equals 2x e to the x plus 3. So y equals 2x e to the x plus 3. So when x is minus 1, y equals 2 times minus 1 times e to the minus 1 plus 3. So y equals minus 2 e to the minus 1 plus 3. So y equals minus 2 over e plus 3. And then that can be rewritten as a single fraction over e. So you'd have y equals minus 2 over e plus 3e over e. And rewriting that, you get y equals 3e minus 2 all over e. So the coordinates of A are minus 1, comma, 3e minus 2 all over e. Okay. So then part D of the question, show that h double dash x is 2x plus 4 e to the x. So that's the second derivative. So you just have to differentiate again. In effect, you're differentiating twice. So we know the first derivative h dash x is 2 e to the x plus 2x e to the x. 2 e to the x plus 2x e to the x. So part D1. h dash x is 2e to the x plus 2x e to the x. So h double dash x, differentiate again. So 2e to the x stays the same. You differentiate it, becomes 2e to the x plus, and we've already differentiated this in an earlier part of the question when we differentiated 2x e to the x using the product rule, and we got for that 2e to the x plus 2x e to the x. So plus 2e to the x plus 2x e to the x. So h double dash x equals 2e to the x plus 2e to the x is 4e to the x plus 2x e to the x. And the format that they wanted the solution given was factorized. So you take out e to the x as a factor. So e to the x brackets 4 plus 2x. And then you can just rewrite that with e to the x on the other side of the bracket. And then the final part of the question, D part 2. So D part 2, and just go back up to the question. Find the values of x which the graph of h is concave up. So the values of x which the graph is concave up. So the condition for a graph to be concave up is that the second derivative is bigger than or equal to 0. So in this case, you have 4 plus 2x brackets e to the x bigger than or equal to 0. So the first part of the solution, you're solving 4 plus 2x bigger than or equal to 0. So rearranging that, you get 2x is bigger than or equal to minus 4. So x is bigger than or equal to minus 2. And then the other part of the solution is e to the x is bigger than or equal to 0. And that's true for all real values of x. So the solution to that is just x is real. So this expression here, 4 plus 2x multiplied by e to the x, this is greater than or equal to 0 when 4 plus 2x is positive and when e to the x is positive. So these are the solutions to that scenario. So when x is bigger than or equal to minus 2, this is positive. And when e to the x is bigger than or equal to 0, which is for all real values of x, this is also positive. A positive multiplied by a positive is always going to give you something bigger than 0. So the solution in this case is that, so you need to look at what is the intersection of those two solutions. X being bigger than or equal to minus 2 and x is real, is that x is bigger than or equal to minus 2. The second scenario in which 4 plus 2x multiplied by e to the x is bigger than or equal to 0 is if 4 plus 2x is negative and if e to the x is also negative, because a negative multiplied by another negative gives you a positive. 4 plus 2x can be negative, but e to the x is never negative, because as we said earlier, that e to the x is bigger than or equal to 0 for all real values of x. So we don't need to worry about the negative solutions. So this is the only solution. X is bigger than or equal to minus 2. I hope this has been helpful, and if it has, then please like and subscribe, and I'll see you at the next one.